Ever sit there and wonder just how big the ocean really is? Or think about the galaxy and what else is out there? Life as we know it still has so many unknown mysteries waiting to be discovered. Audioboom and Life Science present Life's Little Mysteries, a podcast for science lovers wanting to know more about everything around us. Join hosts Mindy Weisberger and Gina Briner of Live Science as they give you the lowdown on all things big and small that truly make you wonder. Mindy and Gina will break down a new topic and 3 mysteries each week. Topics ranging from dogs and what they dream about, to volcanoes and how scientists know when one is about to erupt, to food and why fries taste so bad when they're cold. This original podcast from Audioboom drops every Monday and is available on your favorite podcast app right now. And just for covert listeners, here's an exclusive preview of Life's Little Mysteries. And while you're listening, be sure to search for and subscribe to Life's Little Mysteries in Apple Podcasts, Spotify, iHeartRadio, or wherever you find your favorite shows.
Hello, and welcome to Life's Little Mysteries with Live Science. I'm Gina Briner, Editor-in-Chief of Live Science.
And I'm Mindy Weisberger, a senior writer at Live Science. The world can be a pretty mysterious place, and we at Live Science love to ask and answer questions about mysteries big and small, about ancient civilizations, our planet and solar system, the plants and animals that live alongside us, our bodies and how they work, and technologies that we use every day.
In today's episode of Life's Little Mysteries, we'll take a closer look at one of the most mysterious environments on our planet, the ocean. So what makes the ocean so mysterious?
Well, there's a lot of it. The ocean covers 70% of Earth. The average depth is about 12,000 feet, but the deepest part, which is Challenger Deep in the western Pacific Ocean in the Mariana Trench, is 36,200 feet deep. So there's a lot of ocean, and according to NOAA, 95% of the ocean is unexplored, and about 91% of all the species that live in the ocean are still to be classified.
And the oceans are important. Actual life on Earth began in the oceans. All complex forms of terrestrial life that live on land now, including us, originated in the oceans and evolved over hundreds of millions of years.
So on top of all the species that have lived in the oceans and are now extinct, and the species that live in the oceans now that we don't even know about, all of life on land, again, life that is around now and life that is no longer around, everything came from the oceans. That was the starting point for all life on Earth.
Which is interesting because conditions in the ocean can be quite extreme.
Yes, so this is another of the big mysteries about the ocean, is that there are parts of the ocean where the conditions there are just so extreme that it seems like no life could survive there at all. So the deeper you go in the ocean, as you go farther and farther down from the surface, ocean pressure increases about 14 pounds per square inch about every 33 feet. So by the time you get to around 3,000 feet below the surface, most organisms that have gas-filled spaces in their bodies, such as lungs, those would be completely crushed. And in fact, marine biologists, when they do missions to the deep ocean, often what they do is, we've written about this at Live Science, they decorate styrofoam cups and styrofoam objects, and they bring them down, because what happens is that as they go deeper and deeper, the pressure crushes all the air out of the styrofoam, and then when they go back up to the surface, they have these beautifully decorated objects that are squished down really,
tiny,
really small
and very Twitter friendly.
Yeah, and very Twitter friendly. Yes, there was a popular Twitter hashtag last year, I think, where marine biologists were sharing all of the objects that they brought down to the deep sea. And but it's not just the pressure in the deep ocean.
It's also dark and very cold. It can below 650 feet, which is deep, but the Mariana Trench goes down over 36,000 feet. Average temperatures are 39 degrees.
Right.
And there's also extremes. It can get very cold, and it can also get very hot.
Right. There are also parts of the ocean where you get these just blasts, these jets of extremely superheated water. So these are hydrothermal vents, and they've been known about since
1977.
Right. And they form in volcanically active seafloor regions. So you've got these volcanoes that are under the ocean floor, and
they're spitting out all this mineral-rich sulfur, minerals, all these different, I guess, nutrients, basically, that some extreme life forms can use down there. And microbes convert those minerals into food, and they process it. It's something called chemosynthesis.
Right. So around these hydrothermal vents, they're spewing up water that's heated up to 750 degrees Fahrenheit. And so you would think that, it's down at the bottom of the ocean, so really high pressure, super cold, except for these jets of extremely hot water that are coming out. And you'd think, okay, well, no life could live down there. But around these hydrothermal vents are actually these thriving communities that are very diverse. And these microbes that you were talking about, what they do is they convert the minerals that come out of these jets of water into nutrients that are then eaten by animals and animals around the hydrothermal vents, and then those animals are eaten by other animals. So there are these biodiverse communities that are actually surviving in these very, very extreme environments.
And when scientists have gone down there to hydrothermal vents on remotely operated vehicles, they've seen these, and they're just these crazy, fantastical looking ecosystems that, different colors and giant tube worms. So they're pretty amazing places. And not only are they cool to look at, but scientists think that by studying them, they can identify similar processes, similar environments on other worlds that could support life.
Right, because some of this, some of the mixture of these conditions around hydrothermal vents, these are conditions that might also exist on other worlds. So by better understanding what it is that creates these little deep sea communities and how they can survive down there, that can give scientists ideas for what to look for in extreme environments on other worlds.
So there's plenty of mysteries in the ocean, in the vast ocean.
So many mysteries. But one thing that we do know that is true about all oceans is that they're salty. And most, lakes and rivers are freshwater, but oceans are salty.
It seems like such a simple question. Why is the ocean salty? It's like, why is the sky blue? But when I sit back to think about it, or I bet a lot of people, if they sat back and thought about why is the ocean salty, they might not know the answer.
So why is the ocean salty? So there are a lot of mineral salts in the ocean, and this includes sodium, chloride, sulfate, magnesium, calcium, potassium, bicarbonate, bromide, and all of these minerals originate the majority of them originate in rocks on land. And then what happens is these minerals and these rocks are broken down by acids and rain. They are carried into rivers, and then rivers bring all of this into all this water and all these minerals into the ocean.
If all these minerals are flowing into the river, why aren't rivers salty and oceans are?
Well, some rivers actually are salty in parts, or salty-ish. So there are these sort of transitional zones.
Brackish environments.
Right, estuaries.
Yes.
So in ecosystems, there are ecosystems that are built around the regions where, when rivers start getting close to the ocean, you start getting these brackish environments that are kind of a mix of freshwater and saltwater. So they're a little salty, but they're not as salty as the ocean. But rivers, no. But rivers in general, rivers are not salty. And the reason why is because rivers are replenished by rain, fresh water. So as rivers flow, they're carrying these minerals away into the ocean, depositing them in the ocean, and meanwhile they're
getting more fresh water coming in from rain and runoff.
Exactly. But what happens is that after the river water, with carrying all these minerals, flows into the ocean, over time, water evaporates, but the minerals don't go anywhere. They stay there, and they just keep concentrating and concentrating. So, in fact, the oceans on Earth, when Earth was young, were probably only slightly salty, but over billions of years, the mineral deposits have become more concentrated, which causes varying degrees of saltiness, but which leaves all oceans distinctively salty.
And about how salty are oceans on Earth?
Well, the concentration of salt in seawater is about 35 parts per thousand on average. So to put it another way, about 3.5% of the weight of seawater comes from dissolved salts.
So rivers can carry about 4 billion tons of dissolved salts into the ocean every year. So they're constantly dumping these salts into the ocean while they're getting replenished. And the oceans, while huge, are salty from this.
Right. So, I mean, just to put that into perspective, just in the U.S. alone, about 225 million tons of dissolved solids and 513 million tons of sediment are carried into the ocean every year from rivers and streams, just in the U.S.
And let's say we were to extract all of that salt. I'm assuming that would be a lot of salt.
Let's think about that. If we want to visualize what it would look like if we pulled all of the salt out of the ocean and just spread it out in front of us, what that would look like. So according to some estimates, if the ocean salt could be extracted and spread evenly over Earth's land surface, then that layer would measure more than 500 feet thick. And that's about as tall as a 40-story office building.
Which is amazing amount of salt.
Right now I'm just picturing the New York skyline with all these
too.
buildings that are just buried in hills and layers of salt.
It's beautiful.
Beautiful and very salty.
Join us on this exciting voyage of discovery and downright weirdness as we explore life's little mysteries.
And don't forget to rate, review, and subscribe to the show on Apple Podcasts, Spotify, or wherever you get your podcasts so you don't miss out on new episodes. Life's Little Mysteries is produced in conjunction with Audio Boom as part of their Audio Boom Originals Network.